Hi everyone. Occasionally on the Regents, instead of one of the traditional statement reason proofs, they ask you to do a quadrilateral coordinate proof, which would say something like prove quadrilateral ABCD is a rhombus. Okay, and we saw one of them in the Green Book, and the answer key to that proof, as well as a blank copy of it, will be in the Edmodo folder as well. So first, just some review of proofs. Feel free to pause the video if you need more time to copy anything down. For the 4 steps to a complete coordinate proof to get full credit, step 1 is to plot the points. So if it gives you points A, B, C, and D, you need to plot them and put the appropriate letters next to them. Step 2 is to write out slope formula. Okay, some people may do their coordinate proofs using midpoint or distance. I'm only going to do them with slope. Step 3 is to perform your calculations. So actually perform the slope formula. And step 4 is to write a thorough conclusion. The reason we do slope formula, if we think about the equations of lines, we know slope formula can tell us 2 things. It can show us that sides are parallel or that they're perpendicular to each other. Okay, obviously if they're parallel, they'd have the same slope. If they're perpendicular, they'd be negative reciprocals. So for each of the 5 quadrilaterals that we've learned this year, I'm either going to have you guys do slope 4 times or 6 times. If I say 4, that means the 4 sides of the shape, find the slope of each side. If I say 6 times, also find the slope of the 2 diagonals. If you're unsure, do it 6 times. It's better to have extra than not enough. Okay, the first type of proof you might see is to prove that it's a parallelogram. So for that, you're going to use slope 4 times. And what you want to show in order for it to be a parallelogram is that opposite sides are parallel. Okay, if you picture a parallelogram, that should make sense to us. So a sample conclusion. In that blank space there is where you'd put the name of the quadrilateral, whatever 4 letters they tell you in the question. So quadrilateral ABCD is a parallelogram because both sets of opposite sides are parallel since they have the same slope. You want to remember to relate it back to why you are actually doing the slope formula. Okay, so talk about whether you found parallel lines or perpendicular lines or if it happens to be both. To prove it's a rectangle, you're also going to do slope 4 times. If you remember, a rectangle is just a type of parallelogram, so we're still going to talk about opposite sides being parallel. But the difference between a rectangle and a parallelogram is now that the consecutive sides are perpendicular. Okay, if we think about a rectangle, there's right angles in each corner. So your sample conclusion, quadrilateral ABCD is a rectangle because opposite sides are parallel, they have the same slope, and consecutive sides are perpendicular, their slopes are negative reciprocals. Okay, again, make sure you're relating it back to the slope formula. To prove that a quadrilateral is a rhombus, this one's a little longer, you need to do slope 6 times. Again, we're going to talk about opposite sides being parallel. But the other difference here, and sometimes they'll ask you a multiple choice about this, is that in a rhombus, the diagonals are perpendicular. So you may remember we've done some multiple choice where you had to know that there was a right angle in the middle of the rhombus and then do Pythagorean theorem. Okay, this is why, because the diagonals are perpendicular to each other. Your sample conclusion, quadrilateral ABCD is a rhombus because opposite sides are parallel since they have the same slope, and the diagonals are perpendicular since their slopes are negative reciprocals. Okay, square is the longest one. You need to use slope 6 times again, but we're just going to notice more things when we actually find these calculations. So the first, opposite sides will be parallel, same as all types of parallelograms. We're going to see the consecutive sides are perpendicular. Right, there's right angles in the corner of a square, and we're also going to see the diagonals are perpendicular. So here's my sample conclusion. Quadrilateral ABCD is a square because opposite sides are parallel, they have the same slope. The consecutive sides and the diagonals both form right angles since their slopes are negative reciprocals. Okay. You do have some leeway in how you word your conclusion, okay, but this should be the general gist of it. Relate what you know based on your calculations. The trapezoid I saved for last because a trapezoid is not a type of parallelogram. So we are still doing slope 4 times, so we're going back to that. But now instead of 2 pairs of parallel sides, we're going to see there's only 1 set of parallel sides. Okay, and if you picture a trapezoid, that should make sense. The 2 bases are parallel. A sample conclusion, quadrilateral ABCD is a trapezoid since only 1 set of opposite sides are parallel, since they have the same slope. Okay, here's our first sample coordinate proof. So I've given you 4 coordinates that I've already gone ahead and plotted, so I've already done step 1. And we're going to prove that it's a parallelogram. I'm first going to write out, since I've already done the points, write out what formula I'm going to use. So I told you before it has to be slope formula. You can choose if you want to use y2 minus y1 over x2 minus x1, or if you prefer, you could just do rise over run. Then we're going to actually do our slope calculations underneath that. So parallelogram with slope 4 times, so I'm going to find the slope of all 4 sides. Okay, and I'm just going to use rise over run for mine. So the slope of AB, it's going up 3 over 1. BC is going up 2 over 3. CD up 3 over 1. And DA is going up 2 over 3. We have exactly what we need to. We have 2 sides that match. And look at the picture, they look parallel. And another 2 that match. So we know we did everything correctly, we just have to write our conclusion. Quadrilateral ABCD is a parallelogram since there are 2 pairs of parallel sides and I'm going to add how I know that they have the same slope. Okay, for our second example, we're going to prove quadrilateral ABCD is a rectangle. So there are your 4 coordinates if you'd like to plot them, and I've already done so. I'm going to start off again by writing my slope formula, and once again I'm going to do rise over run. For the slope calculations, rectangle is again 4 times. Okay, and make sure, just like I am, you are clearly labeling the line segment that you're finding the slope of. Okay, there shouldn't just be random numbers on the page. Okay, for the slope of AB, again, I'm going to use rise over run, so just use my picture. Okay, so I can see that it's going up 3 to the right 9, so 3/9. And I'm also going to reduce that to 1/3. I would recommend always reducing your slope, otherwise you may not see that things are parallel. BC, I can see it has a negative slope. It's going downwards, so it's going down 3 over 1. CD, once again, up 3 over 9, which is 1/3. DA is down 3 over 1. We should see a couple things here. Again, just like the last one, we get these 2 matches. That shows us a type of, or that this is a type of parallelogram. However, we also want to show that this is a rectangle. If you think about, again, the difference between a rectangle and a parallelogram, a rectangle has perpendicular sides. Well, if we look at AB and BC, their slopes, they are negative reciprocals of each other, which is what we were looking for. So now we just have to write our conclusion. Okay. If you realize at this point that your calculations don't make sense, go back and recheck them. It should work out unless it happens to say prove it's not a rectangle. Okay, otherwise it should always work. Conclusion, quadrilateral ABCD is a rectangle. Since opposite sides are parallel, they have the same slope. And consecutive sides are perpendicular. Since their slopes are negative reciprocals. Okay, so those are two sample coordinate proofs. Again, in the Edmodo folder, you'll find the one that's also in the green book. Okay, it's from one of the 2013 exams.